So my name is Jukka Hassinen, and I am a project manager in the FinnCERES flagship, which is the competence center for materials bioeconomy. And I'm from Aalto University. So we are utilizing the national treasure of Finland, the forest biomass, so lignocellulose as we call it, and we produce new materials for our sustainable future. So we have here Aalto University and VTT as partners in this flagship, and we are combining the strengths of both of these organizations. So at Aalto we are strong on multidisciplinarity, and we have excellent scientific outcomes, whereas VTT focuses more on applied research, piloting, and global industrial networks. So I'll start by stating that we are facing big challenges when it comes to material production. Our material and energy consumption is over-relied on fossil reserves. And also the way we use materials and resources nowadays is not sustainable, and it's accelerating climate change. So there is an urgent need to transform the existing materials paradigm, so to change the way that we use materials nowadays. And this is actually where we focus on. So in FinnCERES, we develop novel lignocellulose-based materials to address these challenges. So one might actually ask, why lignocellulose? Why is that the solution? Maybe I'm preaching to the choir here, but it's actually not only because of its renewability and sustainability, and not only because it's the most abundant organic compound on Earth, but it's also very complex. So we can make different kinds of materials to fit different purposes. We can functionalize the materials and make them very versatile. Lignocellulose is also very interactive, and it has a multi-scale hierarchical structure, which we can use then to extract compounds from different length scales. For example, we can have molecular level extractives, nanocelluloses, micron scale structures, and bulk wood, of course. And these have, of course, different applications for these materials. So our efforts will help, of course, to mitigate environmental challenges, and we will provide solutions for carbon storage, and we'll also contribute to the circular economy. And we will also accelerate new sustainable business from wood and plants. And this is done by supporting the Finnish industry. So we aim to offer new materials and new technologies for the industry to make added value materials. So we will also accelerate so that the research done will reach the market and the consumers faster. And of course, in order to make a difference, we will engage with the public and the decision makers. So how will we do this? We will, of course, educate the future talents, and then, of course, promote continuous learning. And then, thirdly, we will provide scientific evidence to the decision makers to support the decision making. So as you can see, the FinnCERES flagship is more than just a research project. It's a program in which aims to kind of, let's say, ensure the status of Finland as a global key player in the field of bioeconomy. So what we are doing in FinnCERES right now, so we have divided our research into 4 key areas, which you can see here. And we have under these areas 15 ongoing research projects, and about 150 to 200 researchers are involved in these activities. So here on the left we have 2 more fundamental areas, interactions and modeling and biomass fractionation and modification, where we study, for example, the interactions between lignocellulose and water, because that's very crucial when considering, well, everything what you do with the material. And then we have also modeling to support the experimental research in many scales. And then in biomass fractionation modification, we focus on the disassembly of lignocellulose for example, using novel solvents so that we can extract and isolate, for example, lignin fractions or hemicellulose fractions from the lignocellulosic biomass. Then we have two more applied topics: structured materials and advanced materials and products. And their topics are listed here below. So we have 3 blocks. First block is about biocomposites, structured materials, lightweight materials, and wearables, which have a broad aim to make cellulose the future plastic. Then we have the solutions for clean air and water, which aims to producing purification systems based on wood. And then we have nanophotonics, optoelectronics, and energy harvesting, where we see that the aim would be to use these lignocellulose-based materials in electronics. And the best thing here is that this materials transformation can be done in an economically feasible manner. So it has been estimated that the value of Finnish forest sector could double by the 2050s with the help of these new value-added products, such as plastic replacements, electronics, wearables, shown here on the right. And this will have also, if this realizes, this will have a huge impact also in the Finnish GDP, 3% in 2030. So because one of the topics of this event was artificial intelligence in forest bioeconomy, I thought to take one case example here about using artificial intelligence in materials research. This is about tannic acid, which is the molecule here shown on the left. And our researchers have been generating different kinds of particles from this tannic acid. Tannic acid is a polyphenol which has interesting properties. For example, it's antioxidant and anti-inflammatory molecule. And we would be interested to check if these properties are kind of shape dependent. You can see many different shapes here that the researchers have been producing. So could we predict this particle morphology somehow? And here machine learning comes to help. So when we input the growth conditions and the shapes, corresponding shapes, they were using a method called BOS, Bayesian optimization for structure search. So they could visualize the dependence of the nanoparticle shapes on growth conditions, and then form this kind of visual map and predict what kind of shapes would be coming from different growth conditions. So this is just a simple example about using artificial intelligence in materials research. And lastly, I'll explain a few words about the how to get kind of involved in these activities. So our collaboration with stakeholders and companies. So here we have the FinnCERES flagship, and around that we are building this FinnCERES innovation ecosystem. And this is a collaboration platform in which we offer, for example, networking possibilities with our experts, and then we have company-specific solutions in the form of workshops, etc. And then this is kind of a way to follow our activities, and then when interesting results appear, we expect that new projects will nucleate with the companies who are in the ecosystem. So, and more specifically, this is what we offer. We have 2 levels in our collaboration model. So we have this Be in Touch, which is free of charge. In this you can follow us by attending our annual public seminar. And then we have this Co-Create level, which has a lot of more content. One can influence our flagship's research topics and receive information about our research results earlier than when it goes public. So, and this is 20,000 for large companies, 2,000 euros for small and for SMEs. And so here below you can see our 6 member companies, and of course I'm happy to discuss more further collaborations here in Koli. And if you want to know more about FinnCERES, here you can see our core team. We have 2 scientific leaders, Professor Orlando Rojas from Aalto University and Tekla Tammelin from VTT. And then industry collaboration, we have Petri Silenius and Alina Ruonala-Lindgren. And the last on the row, myself and Stina Grönqvist, who are taking care of the practical matters. And check finceres.fi, and you can also follow us in Twitter. So thank you for your attention.